Let me take a look. Section 2I, fluxes and antifluxes. 2.80 fluxes. Fluxes are substances applied to a metal to prevent the formation of an oxide film or to remove an already formed oxide film. Borax sodium tetraborate combined with charcoal and silica are the main ingredients in most borax fluxes. Fluoride fluxes, aside from containing fluoride salts, are similar in composition to borax fluxes. Fluorides dissolve chromium oxide and work very well for soldering base metal alloys. In the dental lab, fluxes are used in three forms: paste, powder, and liquid. 2.80.1 Paste flux. Paste flux is powdered flux mixed with petrolatum. This form works particularly well for soldering tasks. Cut the solder into small pieces, dip them in the paste, and then place them on the joint. Add more flux with a small instrument if you need to. 2.80.2 Powdered flux. Powdered flux is best for casting procedures. Store it in a container with a perforated lid, for example, a salt shaker, and sprinkle it onto the metal in the casting crucible as required. 2.80.3 Liquid flux. To make liquid flux, mix powdered flux with water or alcohol. This form works especially well when soldering with an electric soldering unit. Dip the solder in the liquid before placing it on the joint. When soldering, you can add a few more drops by holding them between the tips of the soldering tweezers and putting them on the joint as needed. 2.81 Antifluxes. Some soldering tasks need the solder limited to a very specific spot. For example, when building up a contact on the proximal surface of an onlay. It can cause serious problems if the solder flows onto the margin. Substances used to control this are called antifluxes. Ordinary pencil lead, graphite, or carbon works well as an antiflux. Another antiflux can be prepared using chloroform or alcohol and rouge. Shave a bit of rouge into a dappen dish, add just enough solvent to make a thin paint, and apply it with a camel hair brush to the specific area you want on the metal. Section 2J, alcohols. 2.82 Types of alcohol. In the dental lab, alcohol is used both as a solvent and as fuel for alcohol lamps and hand torches. There are several types of alcohol. Some can be used in the lab and some should not. The physical properties of the most commonly used alcohols are described in paragraphs 2.83 through 2.86. Paragraph 2.83 Grain alcohol, ethyl alcohol, ethanol. This is a clear liquid with a strong, distinctive smell. It burns with a bluish flame and works very well as fuel for an alcohol torch. Paragraph 2.84 Wood alcohol, methyl alcohol, methanol. This is a clear liquid with a pleasant smell, produced either synthetically from carbon monoxide and hydrogen or by distilling wood. It is highly poisonous and burns in an alcohol lamp with a reddish-yellow flickering flame. When air is blown in from the bellows of a hand torch, the flame appears slightly purple. One benefit of the yellow flame is that it is easy to see in normal daylight. While it does not burn as hot as ethyl alcohol, it is still adequate as fuel for both torch and lamp. .85 denatured alcohol. One moment. 2.85 Denatured alcohol is a mix of ethyl alcohol plus various poisonous additives that make it undrinkable. Common denaturing additives include methanol, acetone, benzene, and ether. As a fuel for an alcohol torch, it may burn well, poorly, or not at all, depending on how much and which denaturant is present. Because its performance is unpredictable, ethyl or methyl alcohol is a more reliable choice for torch fuel. 2.86 Isopropyl alcohol. Isopropyl alcohol is very similar to ethyl alcohol. In an alcohol torch, it burns with a slightly yellower and somewhat more vigorous flame than ethyl or methyl alcohol. With air pressure from a hand torch bellows, it produces a blue flame, but it smokes badly on wax, so it is generally not recommended for most lab or clinical work. Section 2K, acids, pickling solutions. 2.87 Introduction. 2.87.1 Acids matter to lab technicians because they're used to remove surface oxidation from metal right after castings are taken out of the mold. Used this way, they're called pickling solutions. 2.87.2 acids have to be handled with extreme care. They can blister and burn skin, ruin clothing, and corrode equipment. Baking soda is the antidote for acid burns and should be applied immediately if contact occurs. If that's not available, flush the area with plenty of water. 2.87.3 in dental labs, acids are usually diluted with water rather than used full strength. When preparing a pickling solution, always add acid to water, never the other way around. Ignoring this rule can cause severe burns. 2.87.4 except for hydrofluoric acid, all pickling solutions should be stored in clearly labeled glass containers with glass stoppers. Never mix one acid with another. 2.88 hydrochloric acid. 2.88.1 hydrochloric acid is a clear, highly corrosive acid. Its fumes can damage and corrode tools, equipment, and fixtures. As a pickling solution, it should be diluted with an equal amount of water. Rarely, it might be used undiluted to remove sulfur deposits caused by an overheated mold. 2.88.2 hydrochloric acid slowly dissolves platinum and palladium. For this reason, gold alloys should not be left in the acid for more than a few minutes. United States Pharmacopoeia USP hydrochloric acid is 37% strength by weight. 2.89 muriatic acid. Muriatic acid is a commercial grade of hydrochloric acid and may contain impurities, sometimes giving it a yellowish tint. Like USP grade, it is supplied as a 37% solution by weight. Diluted half and half with water, it works well as a pickling solution. 2.90 sulfuric acid. Sulfuric acid is a thick, oily liquid. It's an excellent pickling solution for gold when mixed 1-to-1 with water. It has an advantage over hydrochloric acid in that it doesn't give off harsh fumes. It works better warm than cold. Okay, 2.91 nitric acid. 2.91.1 nitric acid is a colorless liquid that can turn brown if stored a long time. That color change doesn't affect its properties. It's rarely used in the lab because it dissolves gold alloys that have a high palladium content. 2.91.2 nitric acid is sometimes used when a casting contaminated with copper deposits from a dirty pickling bath can't be cleaned with hydrochloric or sulfuric acid. For that, use a mix of 1 part nitric acid to 2 parts water. 2.91.3 don't leave gold in nitric acid for more than a few minutes. 2.92 phosphoric acid quickly dissolves dental cement and is useful for removing facings or tooth teeth from metal. It doesn't affect the common dental alloys. 2.93 hydrofluoric acid. This acid should only be used to remove porcelain veneers from metal. The fumes are dangerous if inhaled, and it is hard to neutralize on skin. If used, keep magnesium oxide ointment nearby for burns. There are also less hazardous commercial alternatives, for example, Nosan, Trident, Inc., Union, New Jersey. 2.94 Aqua Regia. This concentrated mix is made from 3 parts hydrochloric acid to 1 part nitric acid. It dissolves gold and platinum. It's rarely used to etch the inside of a gold inlay or crown to adjust the fit. Section 2L Wetting Agents, 2.95 Overview. 2.95.1 When water beats up on a wax surface, that's surface tension at work. If wax pattern is invested, that surface tension must be reduced. Otherwise, the investment might not properly adhere to the wax and nodules could form on the casting. 2.95.2 A wetting agent debubbleizer is a soapy feeling liquid used to reduce that surface tension. If a wax pattern is properly treated with the wetting agent, the investment flows evenly over it and into fine details, which helps prevent nodules. Similarly, adding a wetting agent to the water used to rinse the denture mold lowers surface tension, making the cleaning more effective. 2.96 Types of wetting agents. 2.96.1 Commercial brand products. Whenever possible, use commercially made wetting agents since they're reliably consistent. Technicians need to be especially competent in debubbleizers for wax patterns. 2.96.2 Hydrogen peroxide and green soap. A very effective wetting agent for inlay and crown wax patterns is a 50-50 mix of hydrogen peroxide and tincture of green soap. Use the pharmacy peroxide as is, mix in an equal part green soap, and store in a dental cement bottle for repeated use. To use it, put the sprued pattern on the crucible former, then invert the former over the bottle so the pattern is submerged. 2.96.3 Household detergent. Studies by dental researchers at the Bureau of Standards show that regular household detergent works very well when added to water for cleaning denture molds. Just be sure to rinse the mold well with clean hot water afterwards, since detergent residue might contaminate the denture resin. Section 2M wax solvent. Okay. Section 2M wax solvents. 2.97 Introduction. Even if something can dissolve wax, that doesn't mean it's suitable for use in dental lab work. 2.98 Wax dissolving substances. 2.98.1 Acetone. This is a clear liquid with a distinct smell. In dental labs, it's used to make a tacky liquid that holds partial denture patterns to the investment cast. To make it dissolve plastic forms in acetone until the liquid is just a bit thicker than water. Apply it with a small brush to the spot on the cast where the pattern will go. 2.98.2 Commercial wax solvents. These products are made to dissolve wax. They are non-toxic, non-flammable, and safe for acrylic resin. They are effective and much safer than many chemicals, so they're strongly recommended. Section 2N Abrasives, polishing agents. 2.99 Introduction. 2.99.1 Abrasives are materials that wear down softer surfaces. How fast they work depends on how hard each material is relative to the other. 2.99.2 Abrasives are ground into powders and sifted to get the right particle size. In dentistry, they're used as loose powders, bonded to paper or cloth as discs, or formed into grinding stones with binders. 2.99.3 Abrasives can be classified by hardness using the Mohs scale. 2.99.4 See Table 2.17 for a comparison of several dental abrasives, etc. Table 2.17 Types of abrasives, hardness and use. Columns: item, material, Mohs number, use, manner of use. Item 1 Chalk, Mohs number unknown, extremely fine, use to impart a high luster to acrylic resin or porcelain surfaces. Item 2 Rouge, Mohs number unknown, very fine, use to give metal a high luster. Manner of use: a powder mixed with water to form paste, applied with a muslin buffing wheel. In stick form, applied with a chamois or rag wheel on a lathe. Item 3 Cuttlefish, Mohs number unknown, fine, use to finish cold. Discs are mounted on a mandrel and held in a handpiece or lathe. Item 4 Emery, Mohs number unknown, used to trim acrylic resin denture bases and various base plates. Arbor band mounted in a handpiece or lathe. Item 5 Tripoli, relatively fine, Mohs 5, used to smooth metal or acrylic resin. Powder, together with a binder solid in stick or cake form, applied with a rag or brush wheel. Item 6 Pumice, Mohs 5.5, used to smooth acrylic resin or metal. 3 grits, flour, medium, and coarse, applied with a rag or brush wheel. Item 7 Quartz, Mohs 7, use as a whetstone to sharpen instruments or as sandpaper to smooth metal. Discs mounted on a mandrel and held in a handpiece or lathe, also used as an Arkansas stone. Item 8 Garnet, Mohs 6.5 to 7.5, use to smooth metal. Discs on mandrel mounted. Item 9 Carborundum, Mohs 9.5, use to smooth metal. Incorporated into points, stones, or discs, then mandrel mounted and held in a handpiece or lathe. Item 10 Diamond, Mohs 10, used to prepare natural teeth and to cut porcelain. Points, discs, and wheels used in a handpiece. 2.100 Types abrasives. Poly 2.100.1 Chalk, a soft, non-gritty form of calcium carbonate made in Let me take that again. Right. I slipped into paraphrasing last time. Let's do it clean this time, word for word. Please paste or upload that chunk again, and I'll stick to the exact text with no summarizing. Two types of abrasive. 1 second. 2.100. Types of abrasives, polishing agents. 2.1. Chalk. Chalk is a soft, non-gritty form of calcium carbonate. A small quantity, made into a paste with water, is an effective high-shine compound for both gold alloys and acrylic resin. 2.100.2. Rouge. Rouge is a polishing agent used to impart a high luster to gold. It can be used to polish an acrylic resin denture, but it tends to collect in the crevices around the denture teeth. It is not recommended for acrylic resin. Rouge consists of finely ground particles of iron oxide incorporated in an inert binder. Mixed with alcohol or chloroform, it is a very good anti-flux. 2.100.3. Cuttlefish. Cuttlefish is an abrasive used to coat discs used for finishing gold. It is finely ground cuttle bone that comes from the internal shell of the cuttlefish. 2.100.4. Emery. Emery is an impure form of aluminum oxide found in nature as corundum. It is cemented to the surface of heavy paper, and the paper is cut into discs, which are used in the laboratory for smoothing and polishing. Emery is also used as the coating on the arbor bands used for trimming base plates. 2.100.5. Tripoli. Tripoli material is obtained from a porous rock ground to a fine particle size and incorporated in a binder. It is supplied in stick form and is excellent for smoothing both metal and acrylic resin. Tripoli is applied with muslin buffing or brush wheels mounted on a polishing lathe. AFPAM 47-103V1, 15 November 2005. 91. 2.100.6. Pumice. 2.100.6.1. Pumice is a form of sand or silica, which is used in the form of a finely ground powder. Pumice is supplied by the manufacturer in several grades. Flour of pumice is extremely fine in particle size. Coarse, medium, and fine grits are routinely used for a wide variety of smoothing and polishing tasks. 2.100.2. Pumice is usually mixed with water to form a thick paste. The paste is then applied to the work as it is held against a rapidly revolving muslin buffing or brush wheel. 2.100.7. Quartz. Quartz is a crystallized form of silica. It is used in a variety of grits for many types of abrasives. A compact variety of quartz is made into whetstone or Arkansas stone, which is used to sharpen dental cutting instruments. In the form of powdered glass, quartz is glued to cloth and paper and used as a sandpaper disc. 2.100.8. Garnet. Garnet is a crystalline mineral abrasive used to coat discs for smoothing and finishing operations. 2.100.9. Carborundum. Carborundum is a trade name for silicon carbide. Many of the stones, mounted points, and discs used in the laboratory are made with silicon carbide. It is composed of extremely hard blue and black crystals that closely resemble diamonds in shape. These particles are pressed with a plastic binder to form stones and points, or they are cemented to the surface of heavy paper to make discs. Stones and discs are used for smoothing and polishing. 2.100.10. Diamond. Many times harder than silicon carbide. The diamond is the hardest abrasive known. Diamond particles are bonded together and used in dentistry to make mounted stones of various shapes. They are also cemented to the surface of metal to make discs, wheels, and points. Section 20-Laboratory gases. 2.101. Introduction. Several kinds of gases are used for heating and melting operations. Some, such as oxygen and acetylene, are stored in highly pressurized containers with safety caps over the outlets. When the containers are moved or handled, the caps must be securely attached. If the outlets are broken away from the tanks, the high pressures propel the tank like a high-speed missile. Therefore, the tanks must be secured to prevent their movement while they are in use. 2.100.2. Types of gases. 2.100.1. Natural gas, city gas. When organic matter decomposes, it forms natural gas, which is found in the ground in regions that produce oil. Natural gas is used in Bunsen burners and blowpipes for operations requiring heat. When it is mixed with compressed air, natural gas produces a flame of approximately 2200 degrees Fahrenheit.
This temperature is sufficient to melt most dental gold alloys, but not hot enough to melt chrome alloys. If an unusually large amount, more than 1 ounce of gold, must be melted, a hotter flame might be necessary. For example, natural gas oxygen. 2.100.2 Acetylene. Acetylene is a colorless gas with a garlic-like odor. Manufactured by the action of water on calcium carbide, it is marketed in pressurized tanks that provide the torch operator the assurance of constant line pressure. Acetylene gas is used with specially constructed blowpipes for casting and soldering. When acetylene burns in air, it produces a flame of approximately 3,000 degrees Fahrenheit. This is hotter than the temperature produced by a mixture of natural gas and air. 2.10.1 moment. 2.100.3. Propane. Propane occurs naturally in petroleum. Huge quantities of propane are produced when crude oil is refined. Propane stored in pressurized tanks assumes a liquid state. As the pressure is reduced, the propane converts to a gas. Propane and air produce a flame greater in temperature than the flame produced by natural gas and air, but less than the flame produced by acetylene and air. Propane is a cleaner fuel than acetylene, and its use is recommended over acetylene. 2.100.4 Oxygen. The oxygen used in the laboratory is a pure form of the oxygen that is found in the atmosphere. It is used to support the combustion of other gases. Oxygen comes in highly pressurized containers, and proper safety precautions must be taken. If a leak occurs when oxygen is stored in the laboratory, the concentrated oxygen intensifies the burning process. Therefore, the oxygen container must be stored outside the laboratory in a specially prepared isolated area. When pressurized oxygen is mixed with natural gas or with acetylene, it produces a flame of a much higher temperature than the flame produced in combustion of those gases, supported by pressurized air. 2.100.4.1 Natural gas oxygen. Natural gas oxygen flames are used to melt large volumes of conventional gold or to melt ceramic metals. Metals suitable for porcelain fusion have higher casting temperatures than conventional golds. 2.100.4.2 Acetylene oxygen. Acetylene compressed air or an oxyacetylene flame may be used to melt a chrome alloy. Most chrome alloys have melting ranges in excess of 2,600 degrees Fahrenheit. An oxyacetylene flame reaches temperatures of approximately 6,000 degrees Fahrenheit. Special torches are used to burn acetylene. Acetylene flames must not be used on ceramic alloy because the fumes might change the alloy's makeup, which is precisely balanced for creating porcelain bonds. 2.100.4.3 Propane oxygen. Propane oxygen can be used to melt large volumes of conventional golds, ceramic metals, or chrome alloys. Propane is cleaner and less hazardous than acetylene. Due to the risk of carbonizing the alloy, propane is recommended over acetylene, even when melting a base metal alloy. A propane and oxygen mixture produces a flame temperature of approximately 5,500 degrees Fahrenheit. Section 2P miscellaneous laboratory materials. 2.100.3 Articulating paper and articulating film. Articulating paper and articulating film are impregnated with a colored dye that is easily transferred upon contact. Both are used for marking interocclusal contacts when adjusting the occlusion of a fixed or movable prosthesis. 2.100.4 Modeling clay. Modeling clay is pure kaolin aluminum silicate that has been mixed with glycerin to form moldable dough. In the laboratory, modeling clay is used to block out large tissue undercuts before a master cast is duplicated. It is also used to hold casts in position when they are mounted in an articulator. Because it shapes and molds easily, modeling clay is suitable for many other uses. 2.105 Cast spray. Cast spray is used for coating the refractory cast to make a sealed surface to place wax or plastic patterns against. Although the exact constituents are a trade secret, these sprays probably contain polystyrene plastic in a solution. 2.100.6 Mouth protectors, mouth guards. Custom mouth protectors. Mouth guards are made from polyvinyl acetate, ethylene blanks, and preforms. This thermoplastic resin is molded over a cast using a vacuum forming machine. Mouth protectors are worn during sports participation to reduce injuries to the oral tissues, head, and neck. 2.1 2.100. Plastic patterns. Plastic patterns are plastic resin forms shaped as clasp arms, lingual bars, retention forms, etc. They are used to make patterns for cast RPDs. Because they are soft and pliable at room temperature, plastic patterns can be easily adapted to the designed outline on the refractory cast. They are made of ethyl and methyl methylcrylate with added plasticizers. The exact composition of the plastics is a trade secret. They must be stored in a cool place to prevent deterioration. 2.100.8 ceramic fiber paper and ring liner, formerly asbestos strip. 2.100.1 except under highly controlled conditions, the use of asbestos is being discontinued in many industries. Ceramic fiber paper is a commercially available substitute for conventional asbestos stripping. Terms such as Nobestos, KO liner, both commercial brand names, and asbestos substitute are used to describe this material. Because this material is used to line the investment ring in fixed denture and RPD investing procedures, the term ring liner is befitting. 8.100.2 asbestos substitutes are stiffer materials and generally non-absorbent compared to asbestos. Therefore, their use in the dental laboratory is limited to investing procedures only. Other materials are now used to replace asbestos for blocking out undercuts, lining crucibles, and insulating acrylic parts during soldering. 2.109 quick setting epoxy and cyanoacrylate adhesives. 2.109.1 the strengths of these products are so high and their film thickness is so low that they are gaining increasing acceptance in dental laboratory technology. Epoxy and cyanoacrylate glues are used to reunite gypsum cast fragments. 2.100.2 epoxy glue contains enough body to be used as a blockout substance on fixed prosthesis dies. Painted on in a thin film, cyanoacrylate cement is an excellent dye hardener and wax pattern spacer.